Guys, to teach me now. Today we're going to take a look at grade 12 acids and bases. Okay, so 7.3. The water in a certain lake has a pH of 5. 7.3.1 says calculate the concentration of the hydronium ions in the water. So we just simply go to our formula. pH is equals to negative log of the concentration of the hydronium ions. Thereafter, our pH is 5. Then we have negative log. Okay, then what you want to do at this point, you want to divide both sides by the negative. So you're going to have negative 5 this side equals to log H3O plus. Okay, and then to get the anti-log, you will just have to say 10 to the power negative 5 is equal to the concentration of the hydronium ions, which should give you 10 to the negative 5 moles per decimeters cubed. Very simple. Okay, and then the volume of water in the lake is 4 times 10 to the power 9 decimeters cubed. Then we have that lime, and then calcium oxide is added to the water to neutralize the acid according to the following reaction. 7.3.2. If the final amount of hydronium ions is 1.26 times 10 to the power 3 moles, calculate the mass of the lime that was added to the lake. Okay, so what we want to calculate now first is the amount of moles that we have. We have the concentration of the water of the hydronium ions, remember, from 7.3.1, and then we have our volume. So we would want to calculate the number of moles present in the final reaction once the reaction has occurred. So we're going to say concentration of hydronium ions equals to N over V, and then our C is 10 to the negative 5. We don't know what's our N. Excuse me. And then our V is 4 times 10 to the power 9. And then you cross multiply to solve for N, and your N should be 4 times 10 to the power 4 moles. So these are the final number of moles that we have. So we need to get the number of moles. No, sorry. These are the number of moles which we had initially. So these are the final number of moles. Now we have to find the number of moles which reacted. So number of moles of hydronium ions which reacted equals to the final number, the initial number of moles minus the final number. So it's going to be 4 times 10 to the power 4 moles minus 1.26 times 10 to the 3 moles. And then your final answer here should be 3.87 times 10 to the power 4 moles. Okay, now we can look at our ratio, which is occurring between calcium oxide and the hydronium ions. Because now we have 3.87 times 10 to the power 4 moles this side. And from our ratio, we can see that Whatever calcium oxide is, the hydronium ions should be 2 times that. So we need to find half of this. So you will just simply divide by 2, and then you'll find that the number of moles of the calcium oxide is 3.87 times 10 to the power 4 divided by 2 due to the molar ratio, which is 1.94 times 10 to the power 4 moles. Okay, now you have your number of moles. This means that you can get your mass by going to N is equals to small m over capital M. So you have your number of moles, and you do not know what small m is. You can find capital letter M from the periodic table. So you're going to look for the mass number of calcium, and you're going to look for the mass number of oxygen. So the mass number of oxygen is 16, and the mass number of calcium is 40. So 40 plus 16 should give you 56. And then you just multiply and find that your mass is 1.09 times 10 to the power 6 grams.